Okay, we're going to be doing notes on implicit differentiation. So let's talk about, before I get to implicit, let's talk about explicit, which is something you've been doing the entire time. I just haven't used the verbiage saying, hey, this is explicit. So explicit functions are when you have like a y equals, and a y equals with some x's or whatever. That's explicit, and we've been doing a bunch of those. Implicit is when you're going to start to have not just y equals, but you're going to have like a y squared equals, or y's can be kind of tangled in there. That's when we're going to start to have implicit. And implicit really is based on a lot of chain rules. So as I go through this first example, I'm going to really be just pushing through this idea of it's a lot of chain rule. Okay. So implicit differentiation is when you differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. We're going to collect the terms with dy dx on one side, and then we're going to solve for that dy dx. Okay, so an example like this right up here, if I find the derivative, what's the derivative of y? It's dy dx equals, what's the derivative of x squared? It's 2x. Now, since I took the derivative of x, it's 2x times dx dx. Now, I never wrote that before because, well, what happens? What's dx over dx? It's going to turn into a 1. And this is going to be minus, the derivative of 5x is 5 times 1 times dx over dx. And again, that's going to turn into a 1. And the derivative of 7 is just 0. So that's why for this, I'm going to get dy over dx equals 2x minus 5. I have always, up to this point, skipped this dx over dx step because it just wasn't necessary. But anytime you take the derivative of a function, the bottom is always what you do it with respect to. Okay? So when I go to this problem right here, it says find the equation of the tangent to the circle at 3, 4. So for the equation, I need this. Y minus y1 equals slope x minus x1. In this case, our slope is going to be dy over dx. So I need to find dy over dx. So we're going to come over here and do that. So the derivative of x squared is going to be 2x dx dx plus the derivative of y squared is 2y dy dx equals the derivative of 25 is, it's just a number, so it's 0. So on the left-hand side, I'm going to just get 2x, dx dx cancels out, plus 2y dy dx. And that's going to equal 0. Now, I'm going to go ahead, that was step 1 right here, differentiate. I'm going to go ahead and collect the terms, and with dy dx on one side of the equation. So I need to get dy dx by itself. So I'm going to move that 2x over by subtracting it. So I'm going to get 2y dy dx equals negative 2x. And then I'm going to divide both sides now by 2y. dy dx is going to equal, the 2 is going to cancel out, negative x over y. Show you the entire thing right there. Okay. So now I need to go ahead and plug this in to get the slope right there. So dy over dx of the point 3, 4 is going to be plug in the 3 for the x and the 4 for the y, and that's my dy dx. So come back up here in red, y minus y1, it gives me y1 is 4, equals, the slope is now negative 3/4, x minus 3. If this is multiple choice, you'd probably need to go solve for it, but this one we'll just leave it be. Because if this was free response, you'd be totally good on this one. So that's implicit differentiation in a nutshell. Let's go ahead and do one more example, a little bit on the tougher side. Okay, so we're going to differentiate this. So on the left-hand side, when I take the derivative of a sine function, I take the derivative of the outside first. What's the derivative of sine? It's going to be cosine. Inside stays the same. Times the derivative of the inside. What is the derivative of the inside? well, the derivative of x is dx over dx. I'm going to write that as 1. So I'm not going to write dx over dx anymore. That's just 1. Plus the derivative of y is dy over dx. Make sure anytime you take the derivative of y, it becomes a dy over dx. It's also known as tagging it. That's another way that I mention it. If you take the derivative of y, you have to tag the derivative with a dy dx. You don't need to tag the x because it's just dx over dx. And that's going to equal, and this is kind of hard for some people to recognize sometimes, but this is product rule. We have a y squared times a cosine x. Those are two different functions. You got the y squared, you got the cosine x. So when you take the derivative of the first, you're going to get 2y, tag it, dy dx, leave that alone, the cosine, plus leave the first alone. And then derivative of cosine is going to be negative sine of x, dx dx. It's 1. Don't need to write it down. Okay. Make sure you put this in parentheses right here so it doesn't look like it's a minus sign, because it's not. It's a negative 1. So let's go ahead and clean this up a little bit by distributing on this side. So I'm going to get cosine of x plus y plus dy dx cosine of x plus y. And on this side, I'm not really doing too much cleaning up. I'm going to do 2y cosine of x. I'll put my dy dx last. I don't know why I put it last. This one I put it first, this one I put it last. It does not matter. Minus sine of x times y squared. Okay, why did I rearrange this? I don't really know. I don't know. Just go with it. It doesn't really matter what order it's in. Now when you get my dy dx is on one side, so I'm going to keep this over here and get rid of the cosine. So over here, I'm going to subtract cosine x plus y. And actually, I'm going to get rid of this negative 2y cosine x dy dx because I need this entire term over here. So 2y cosine x dy dx. So I'm left with dy dx cosine x plus y. I didn't touch that on the left-hand side. Move this over now. So minus, I'll just put the dy dx in front now. Dy dx 2y cosine x. And this sign, we're going to get the two negatives here. So we're going to have negative sine of x times y squared minus cosine of x plus y. Take out a GCF on this side so I can get the dy dx by itself. So this is going to get pretty algebra heavy here. So cosine of x plus y minus 2y cosine x equals negative sine of x times y squared minus cosine x plus y. And then divide this entire thing over here. And that's actually all we need to do. It's going to look ugly. That's okay. Make sure it's on the screen. Okay, it is. And then this is going to be cosine of x plus y minus 2y cosine x. All right, so this is all good right here. If you ever wanted to divide out that negative, you could make everything on the positive. It's just these two things down here would just flip-flop, but it's not going to matter for this at all. So that is just the first day getting your feet wet into implicit differentiation.